Hi everyone, welcome back to my channel. In today's video, I will try to make, let's say, a really project which is contains, let's say, a spam detection or let's say handling the text data or numerical data. And this I will show you step by step. But before going to the implementation, I have just in my mind. So, for instance, when you deal with machine learning, this is, or let's say the pipeline, the normal pipeline, and let's say assume that I have a data. Now I will pre-process the data, do the training, prediction, and the evaluation, right? And this is when I have only one, let's say, one data set or maybe one algorithm. So now if I am assuming that I'm using a support vector machine for spam email detection. So next, what I would like to, let's say, to apply the decision tree on the same data set. What will I have to do? I will just have to change the training algorithm, right? And for the beginner, let's see, he will duplicate. Let me just He will duplicate this implementation, which is, let's say, it could, for instance, it could work. I mean, it should work, but the problem now here is duplicating the code. It's not easy. Let's say after a while, it's not easy to maintain. It's not easy to extend it. And assume that you will use, for instance, logistic regression. You will duplicate the same code. So now the idea here, I'm just showing you real project plus the right structure for your code. So as I said, this is let's say the normal pipeline. But before this, I have, for instance, I need a data, right? And the data could be text, numerical, images, any other data, let's say, type. And the pre-processing, each data type, it's need a pre-processing, its own pre-processing. For instance, for numerical data, you need to take the mean, median, max, I don't know. And for the text, you need to convert the text to vectorization and do this processing. And regarding the algorithm, some algorithm has several, let's say, parameters and different, let's say, prediction. So this has to be, let's see, taken into account before the implementation. So let me just show you this diagram. This has to be deleted. Okay, let me just remove this. Now, as you can see, this is the pipeline. So load the data, pre-process, split the data into train and test, training the model, make the prediction and evaluation. This is the normal pipeline. This we have seen in the beginning. So now for the data, as I said, for the data, it could be I have different data sets. I mean, different type of data sets, text, images, numerical, and etc. And also pre-processing. So now for the data pre-processing, you have to create abstract class. So abstract class has two, several functions. It depends on your needs. So for instance, what I have here, load data set from file from, let's see, in this, I'm just trying to have it from file, but in your case, maybe in the future, I will try to update it to have a data from TCP protocol, or maybe from directly from a camera, or it depends, or maybe from the any endpoint. So let's say I have this data base data handler. This is only, let's say, the base class of the data. And for the data here, I have a spam data and raisin data set. So it's only just to show you the text and the numerical data set. So this both data sets have downloaded from the Kaggle. And this spam class will be inherited from this, and it will try to use load, pre-processing, and the extract features, and label will be, let's see, will be private. So plus public and private minus is, let's say, private. And this, for instance, it has pre-processing, which is plus if it's transform. Sorry. And regarding this is, for example, from step 1 to 2, load and preprocess. Now the step it will this step it will be in the main, because try to split as much as you can. So don't try to put all of this code in one file. So indeed, if you would like to change, if I would like to change the data, let's say the pre-processing for this data, so I will just change only this part here, and the other bus will be as the same. Only this file here will be changed. And assume I'm trying to add, let's say, another matrices. I will just add it here directly without any changing of all of these components. So this is the advantage of a well structured. So in this case, I can reuse this code. I mean, it's support reusability, modularity. So this, for instance, is one modular, this one modular, and this one, etc. And as extensibility. So you can extend it to whatever you want. For instance, in this case, I will add here, for instance, image data handler. And if I have image data handler, I will load the images, let's say pre-processing the images, and after that, I will just put the data as a training and label. For instance, this is for classification. So let me jump to the code, and as you can see here, this is a base class. The base class has uh, two different, let's say, two or three, let's say four steps. Let me just zoom in and zoom out. So why I have, let's say, created a base class. The base class or using interfaces is like a contract. So it will make, let's say, your code very consistency. So if you use a training, if you use, let's say, decision tree, support vector machine, any other algorithm, they will have the same functions: train, evaluate, predict, and etc. And if you have, let's say, in case you need more other functions, you can make it as a private or maybe public in the child class or the derived class. So here I have the base class. So as you can see here, I have train, evaluate, and predict. And if I need to add another function, I will just add it easy here. And for the other function, it will be used directly. So I'm not quite sure if I need to explain this, but let me just do it. The video maybe will be a little bit long, but this is the training. This is the I'm using, by the way, the Skyline functions. But let me just close this, and let me just see. This is the base class train and predict. And by the way, this could be also more, let's say, organized. But this is, let's say, not the best, but it's good to have it. So now let me just go to the decision tree. So in the decision tree, there is a decision tree classifier, which is already implemented in Skyline. And for the decision tree class, I have this. This is created by me. And in the decision tree, it's inherited from the base classifier. So what does that mean, inherited? So if it's inherited, it will have the train, evaluate, and predict, and these other functions. So I can use it with this function. And you can see here I have initialized the super class. Let's say the parent class with this super, and it has the type and the argument if you have arguments. And here I'm initializing the model here, and the model is initialized by Skyline with these parameters. And this model here, as you can see, it's used in a base class. With sometimes you see where is this defined? For instance, with the model. And you see where this is defined. As you can see, it's not defined anywhere here. So it's just defined in this function, in this class, sorry, and it will be used. This module will try to use this train and fit and etc. And let me jump to the main, just to make it clear. So here I have created a classifier, and the parameters, I have no parameters for this classifier. As you can see, I defined it here. And the decision tree will go to the classifier, this one here, and create a decision tree classifier which is defined in Skyline. And with the classifier is used, so because I have used several classifiers here, so the classifier, as you can see, I can use train function, which is used in a base classifier. I can use the predict, which is also defined all of these. And all of these functions, as you can see here, let me just, if I just see this one here, just to remove it to make it clean. So I have defined a classifier, which is initialized from this class. And now I can train, predict, and evaluate of this classifier here. And it's the same for the rest. If you see it, for the example, for the support vector machine, support, yeah, it's inherited from base classifier, so I can use the predict and evaluate, and it also the same as the decision tree. Now let's go back to the data class. As you can see, I have a data class as a let's say interface class. I have I have seen this load data, which is, for instance, reading the data from CSV file, and extract the file, extract the functions. As you can see here, it's defined as a private, and it this function here, extract function, it depends on the dataset itself. So I will not have any implementation for this, so it means I have add pass. For the pre-processing as well, I have no processing specific processing for this. What I have done here, anything is common between all of these data, it will be, let's see, written here. If any data, if the data it has different pre-processing or different post-processing or different functionalities, just you need to add the functions, add pass, and this functions will be redefined, or let's say overwritten in the derived class. Let's let's have example. For instance, I have spam data handler based which is inherited from this, inherit all of these functions. And now, as you can see here, extract function, it will be written, overwritten, and I will have my implementation, let's see here, for the features. And for the pre-processing, I will have this. And for this data set, it's a numerical data set. I will just extract these features, and the pre-processing, it's just standard scalar. And yeah, so now if you see, I have in the main, I have defined this spam data. I'm using this now. Let's see. And if I run this, I will have, let me just base classes, base classifier. Let me just comment this out because it will show the plot and stop. Let's see, at a certain point. Let me just run, and you can see this. It will start with the decision tree, I think. If we go to main, we can see which one is the first decision tree, the first one. And you can see here, for example, the decision tree, I have the confusion matrix classification report, and this is for the data. Oops. This is for the same data set. As you can see here, I'm using the spam data set. And now you can see which let's see classifier is the best. Try to compare the confusion matrix if your data is balanced. If the data is not balanced, try to use precision or recall or F1 score. And you can see here the AUC is, for instance, for support function machine is 1, which is perfect. That is, let's say our classifier or our the support function machine is perfectly split these two classes perfectly. And let me just see, you would like to add it to use the raisin dataset. For instance, I have the dataset here. I just need to copy this. And instead of this, I will just try to use this one here. Now it should work directly without any issues. I hope so. Because each data has the loading, I mean pre-processing. Okay, where's okay, sorry. I have just add data. I have to remove one data directory. And you can see all the components, other components I haven't touched anymore. So because it has to stay the same. Okay, and you can see here it's none. This I will have a look why it's none. Yeah, this is I think one real project for the spam email detection. Okay, sorry, I haven't shown you the emails, right? Let me just go to the emails and see the dataset. As I said, the dataset is downloaded from the Kaggle, and you can see this is the spam. Let me just see. Um, Not spam. Let me just see where's the other class. Or each one message it has the class label. Let me just go here. So text spam subject. Okay, why it's not showing? Yeah, anyway, this is the data set. Let's say extracted, downloaded from the Kaggle, and every email it has a class label. And if you go to classes, I mean data class, and you can see in the data handler, I have I have used this. This is the data, the text dot value, which is, and now it will be replace a spam with one or maybe a zero if it's ham or spam. And for the pre-processing, you need to count vectorize, which is, let's say, creating a bag of words for the whole data set. It will make it, because if you see in the text, every email or every has a different length. So to make it equal length, we need to use a bag of words. Let's see. And let me just run this and see what is in X and in Y. And I think this is, let's see, an overview. I have shown you a real example spam email detection plus the good structure of your data set. So I think this should be enough for today. And so you can see I have 5,000, almost 5,000, 6,000 message. You can see this is the Y, it's the class label. You can see spam, spam, and also 6,000. Sorry. Yeah. Okay, I think this is enough for today. And if you like it, please subscribe into my channel and like the video. And if you have, of course, any question, write it down below. I also upload this code to the Git so you can have a look. I think it's already uploaded to the Git. Let me just check. Not yet. So I will just upload it right now. Okay, thanks for watching and see you next time.